So guys, once again welcome back to Ahoy Navigos. Today we are going to discuss about trim type A problems, continuation that what we did in our last videos. So let's see, in front of us we have the table to solve trim problems, which one we will be using all types of trim problems. We will use this table to solve all problems. So let's see our first question. This is type 3 problem, load or discharge several weights. So the question is, the present drafts of a ship whose LBP is 142 meters are 10.2 meters and 11.6 meters forward and aft. MCTC is given as 170 10 meter, TPC 3232, HF is given as 3 meter aft. Find the final drafts forward and aft after the following operations have been carried out. We have A 1500 ton cargo discharged from number 2 low hold 43 meter forward of midship. That's H is midship, G is center of gravity for that weight, it's 43 meter forward. We know to calculate our moment we need the distance from center of flotation. So as we see, it's H, it's given your weight is 43 meter forward of your H. So that means 43 meter forward of your H. So, and in question it is given that your F is 3 meter aft of H. That means somewhat here, F is somewhat here 3 meter. So your F2 COG of that weight is 43 plus 3, 46. Similarly, the second weight, 2000 ton cargo discharged from number 4 lower hold, 37 meter aft of midship. That means if H is midship, its COG of the weight is 37 meter aft of midship, and it's given in the question your center of flotation is 3 meter aft of midship. That's it will be coming somewhat here, and the distance H to F is 3 meter. So you can say from center of flotation to COGW is 37 minus 3, 34. Similarly, the third one, 500 ton fresh water received in number 3 DB tank, 33 meter forward of midship. So it's midship, 33 meter forward, and HF is given as 3 meter aft. So you can say the weight distance from F is 3 plus 33, that's 36. So next thing, we will write our initial drafts in our table. So that's 10.2 and 11.6 as given in the question. Next thing what we need to find is mean sinkage or risage. For that, we have, first of all, we will find what is the distance from aft to your center of flotation. That means HF is given as 3 meter aft. So aft to F we can say LBP by 2. That's, you will get midship. That's 142 divided by 2 minus 3 meters. You will get 68 meters. It's 3 meters. 68 meters. Next thing, we know mean risage or sinkage. That's equal to, since we have many weights in the last questions where we have only one weight, what we did was weight divided by TPC. This case we have several weights, so the mean rise or sinkage will be total weight loaded minus total weight discharged divided by TPC. So here in this case we know 500 we load, so we write 500 L for load and D for discharge, 2000 discharge, 1500 discharge. If you add all loading and discharging, it's 2000 plus 1500, 3500 discharge minus 5500 load, that is 3000 discharge, and that divided by TPC, that's 32. If you do, that's 3000 divided by 32, you get answer 93.75 centimeters, that's 0.938 meter. Since discharge is more, we can say it's a risage. So we write the values in our table. It's risage, so minus 0.938, both forward and aft. Next thing what we need to find is TA or TF. So to find TA, we need TC. So finding TC, MCTC is given in question, we need to find trimming moment. And the answer is always centimeters. So to find trimming moment, in the previous case when we had only one weight, it's just weight into the distance from COF. In this case, since we have several weights, it's W1D1 plus W2D2 plus W3D3 since we have 3 weights. So the initial one is 1500 into its discharge from forward of midship. That means, and the distance we calculated 46. So 1500 into 46. And if we discharge from forward, we will be having a moment by aft. So we represent the moment aft by A and moment forward by F. Next thing is 2000, discharge from 37 meter aft. That means you have a moment forward, that's F, and you have the final one, 500 ton fresh water, we loaded forward, so we have moment forward. So if we do 1500 into 46, we get 69,000, Next thing, 2034, we get 68,000. When you do 536, we get 18,000. So aft, forward and forward, and the final will be, if you add all aft and forward and we subtract it, we get 17,000 forward, that's by head. So we got the trimming moment as 17,000 by head. So we know TC, trimming moment divided by MCTC. Trimming moment we found 17,000 divided by MCTC in question 170, and the answer is 100 centimeters, that's 1 meter. So equation we know, TA is equal to AF by LBP into TC. AF is equal to 68, we found in the question, divided by 142 into TC is 100. So that's 47.9 centimeters, that is 0.479 meters. So we write that. Next thing, TF, we know TC minus TA, that's 100 minus 47.9 centimeters, that's 52.1 centimeters. In meters, it's 0.521. So we know TA and TF. Let's go to the table and put the values there. So since in the question it's given, it's trim by head, so we said whatever the trimming moment is, we add there. So since it's by head, we add TF and we subtract TA. So the values will be plus, since forward TF we add 0.521, and TA we will minus it from aft draft minus 0.479. So the final drafts is sum of these three. So the forward draft is 9.783 and 10.183. So we get our final drafts. We can write our final drafts as forward 9.783, aft as 10.183 meters. So guys, this is type 3 problems. So now let's go into next type of problem. Now guys, we have type 4 problems. The concept of this type of problem is to finish at a desired trim. You will be given in question, you need to finish your ship loading at a certain trim. So we see how we do these problems. You have the question, a ship LBP 200 meters, MCTC is given as 300 ton meters, TBC 35, HF is given as 5 meter aft, is presently drawing 7 meter forward and 11 meter aft. Calculate present hydrostatic draft. We need to find our initial hydrostatic draft, and we have space available for loading in number 1 lower hold. HG is given as 80 meter forward of midship, that's H to G, that's H is midship, and number 4 lower hold HG is 30 meter aft. And calculate how much cargo to put in each of the two spaces. We are given two spaces where you have space for loading, and we need to find how much cargo we need to put in each space. And also it's given you need to finish at a hydrostatic draft of 9.6 meters. Also the ship should be trimmed by 2 meters by the stern. We need to find our final drafts forward and aft. So let's see how we do that. First thing, as we do usually, HF 5 meter aft. So we find AF, that's LBP by 2, you get midship, minus 5 meters aft, that means 95 meters. Next thing, let's go to the table and let's put the initial drafts, forward 7 and aft 11. So as in the question, you know number 1 lower hold and number 4 lower hold. The distance is given from midship. We need to find it from center of flotation, because in type A problems we use the moment from center of flotation to the weight. The dV, what we use in our equation for trimming moment, WD, the D is from center of flotation to the center of gravity of the weight. So since it's given from midship, it is given initially for number 1 lower hold 80 meter forward. From H, its COG of that weight is 80 meter forward. And in question it's given as F is 5 meters aft of H. That means the COG of the number 1 lower hold is 85 meters from center of flotation. Similarly for number 4, H is given as COG is 30 meter aft of H, and it's given F is 5 meter aft of H. So we can say the distance is COG to F is 30 minus 5, 25. So now we need to find from the table, you can see mean sink gauge or rise age. So to find mean sink gauge or rise age, we need to know weight divided by TPC. Since we don't know the weight, so let's see how we find it. First thing what we need to find is hydrostatic draft. We know, as we learned before, for finding hydrostatic draft we can use this equation, aft correction, AF by LBP into trim. So what's our initial trim? It's 7 and 11, so that's 4 meter. So the equation aft correction is AF by LBP into trim, that's 95 divided by 200 into 4 meter trim, that's 1.9 meters. That's your aft correction. That since your stern by trim by stern, so what we use is half draft. Hydrostatic draft is half draft minus your correction. Since trim by stern, that's 11 minus 1.9, that's 9.1 meters. Next thing, In question, it's given your final hydrostatic draft, that's 9.6. So if you know initial hydrostatic draft and if you know final hydrostatic draft, you know the sink gauge. That's 9.6 minus 9.1. Sink gauge is 9.6 minus 9.1, that is 50 centimeters. Let's put sink gauge in our table. It's plus 0.5 since we are loading something. Next thing, what we need to find, if you know the sink gauge, you know the equation for sink gauge. That's W by TPC. You know TPC from question, you know sink gauge. You can find the total weight loaded. So the total weight loaded, cargo loaded, W will be 50 into TPC. That's 50 into 35, 1750 tons. So this is the total amount of cargo to be loaded in our ship. So that's a cargo to load. Next thing, we know in the question it's given we need to have a final trim is 2 meters by stern, and initial trim we already discussed 11 minus 7, that's 4 meters. Present means 4 meters. So we can say the trim cost is 4 minus 2, 2 meters, that's 200 centimeters. Next thing, let's go into our equations. We need to find our trim cost, we know. We need to find trimming moment, and MCTC we know. So if we use this equation, only unknowns will be, you know, the D we already calculated as in here, 80 plus 5 and 30 minus 5. So if you know that, we can use that equation to find our weight. Since cargo to load is 1750 as we already found, so let cargo to load on number 1 lower hold be X. Let's put a variable for that X, and cargo to load on number 4 lower hold to be 1750 minus X. So we can say trimming moment is equal to, since we have two weights, W1 D1 plus W2 D2, both are loading. So that will be X into, W1 is X we considered, into 85. W2 we consider as 1750 minus X, and the distance is 25. We already found in our thing. 80 plus 5 for number 1 lower hold, for number 4 lower hold is 30 minus 5. So that's 85 and 25. So next thing, trimming moment is by head. How you know that? Because you know number 1 lower hold we are loading 85 into X, and in the other one it's 25 into X. So it's 85 into something, so mostly this value will be higher. So it's trimming moment by head. We can't exactly say that now, since we have only, we don't know the weight. So when we find the weight we can exactly say that, but for understanding we can say it's trimming moment by head now. So TC we already found, it's 200 meters. So TC is equal to trimming moment divided by MCTC. We know MCTC. So that is 85x plus 1750 minus x into 25 divided by MCTC. That's 300. That will be equal to 85x, and you open these brackets, you multiply it with it. The answer will be 85x minus 43750 plus 25x divided by 300. That will be equal to your TC. TC we already found, 200 centimeters. So when we bring this 300 to 200, it will become 60,000 is equal to 85x plus 25x 110x minus 43750. From this we can find the value of x as 60,000 plus 43750 divided by 110. It's 943.2 ton. So we got the value of x, that's the cargo to load on number 1 lower hold, since we said cargo to load on number 1 lower hold is x. So we can find cargo to load on number 4 lower hold will be 1750 minus x, that's 1750 minus 943.2, 806.8 tons. So we got the value of both the weights to be loaded in both the spaces, that's number 1 lower hold and number 4 lower hold. Next thing what we need to find is our drafts. So since our table, you know, we need to find our TA and TF. So for finding TA we need to find TC. We know the trimming moment now, we know the MCTC. So let's go. So we can say TC we already found, it's 200 centimeters. So TA will be AF by LBP into TC, that's 95 by 200 into 200, that's 95 centimeters. So it's 0.95 meters TA. And the next thing is TF is equal to TC minus TA, that's 200 minus 95, 105 centimeters, that's 1.05 meters. So next question is, where is the moment? By head or by stern? So you can see in your question, you apply the value of x and 1750 minus x, and you multiply. You can see this value will be higher than this value. This is number 1 lower hold and number 4 lower hold. Since number 1 lower hold is at the forward part of our ship, you can say your ship will be trimming moment by head, since you are loading more cargo there, and that distance from the COF is also larger, so that moment will be higher on the head. So we can say the ship is trimming moment by head. So we add TF and we subtract TA. So let's go to our table. So the value of T and TF we know. So we add to forward plus 1.05 and to aft we minus 0.95. If you add these values 3, you will get your final drafts. Final drafts is 8.550 and 10.550. So you get the values of your drafts. So you can say your final drafts as forward 8.550 and aft 10.550. So you got the values both. So guys, this is all about it. We'll be discussing 3 more types of problems of trim in further videos. Stay tuned to Ahoy Navigos. This is Ahoy Navigos signing off. Thank you.